Right, welcome to our video on determinants, and you'll notice that the title of this is Determinants of Square Matrices because you cannot find the determinant of any matrix that isn't square. So that's a really important thing to note as we begin this video. So some applications for finding determinants and why we would even want to use determinants we'll look at in the next lesson, but some of those things might be finding the area of a triangle, coding and decoding messages. We're going to look at determining whether or not 3 points are collinear, lots of different types of things. So to find the determinant of a matrix, of a 2 by 2 matrix, we will take the product of AD and subtract the product of BC. So we're looking at matrix A here. And a couple of things to note. First of all, notation for a determinant looks like an absolute value symbol. It's not. That means determinant. So when we use what looks like an absolute value symbol around the name of a matrix, we're saying find the determinant of that matrix. Secondly, you'll notice that this AD minus BC should look really familiar. And that's because that was part of what we found in order to find the inverse of a matrix. So let's go ahead and just do a couple of these 2 by 2 matrices, find the determinants of them, and then we'll look at something a little more complicated. So to find the determinant of a 2 by 2 matrix, we would do, so if I want to find the determinant of matrix A, I'm going to take A times D, which is 1 times negative 1, and I'm going to subtract B times C, which is 3 times 2. And what I get is negative 1 minus 6, which is negative 5. Now this is interesting because this is an operation that we did to a matrix that did not result in a matrix. So this is the first time that we've actually seen this type of situation happen. We're finding something that has to do with a matrix, doing some kind of matrix calculation, but what we get is not a matrix. It's a number. So the determinant of matrix A is negative 5. As I said, we're going to look at the applications of this in a future lesson, but for now, just knowing that the determinant is going to end up with just a number is really important. So let's go ahead and find the determinant of matrix B. So once again, I'm going to do 5 times 2, A times D, yes, 5 times 2. And I'm going to subtract negative 4 times 0. All right, so I get 10 minus 0. So the determinant of B is just 10. Okay, go ahead and pause the video here and work through finding the determinant of C and come back and check your answer. So unlike inverses, it is okay to get 0 here because 0 is a value. We can go ahead and say that the determinant of matrix C is just 0. All right, let's move on. So there's a second approach that we can use to find the determinant of a matrix, and it especially comes into play when we're dealing with larger matrices. So in this case, we're going to focus on a 3 by 3 matrix, and I want to explain what you're seeing here. So first of all, you'll notice that the first column, A, D, G, and the second column, B, E, H, you can see how they were just lightly copied right outside of the matrix. Those are written as an aid to help us find the determinant. They are not, we're not adding on to the matrix in any way. We're just using that to help us in our method. So the second thing you'll notice is that there are some red diagonal lines and some purple diagonal lines, or blue, depending on what your monitor looks like. Each of those represents finding a product. So on the red diagonals, these here, we're going to find the product of the 3 numbers that I highlighted. So I would find the product of AEI, the product of BFG, and the product of CDH. And then you'll notice that underneath each of those, I have a little plus sign. That plus sign means we're going to add those products together. Then we look at the products on the blue diagonals. Okay, so you'll notice a couple of ways that you can do this. I like to think about starting with the red diagonals, starting with the element in row 1, column 1, and with the blue diagonals, I start with the element in row 1, column 3, and I highlight the diagonals. So now I've got these 3 diagonals, CEG, AFH, and BDI, and you'll notice that below those 3 diagonals, I have written a minus sign because we're going to subtract those. So what I do is I find the product of those diagonals, and then I just do this big sum/difference. So let's go ahead and try that with matrix A written below. So the first thing I'm going to do is enlarge this a little bit so we can kind of work this through a little bit easier. But the first thing I do is I write the first 2 columns outside of the given matrix. And I try to space them out as evenly as they are spaced out in the actual matrix themselves. I want it to be a relatively uniform spacing because it'll make my diagonals a little bit easier to draw. Now the next thing I'm going to do is I'm going to start with my red diagonals, okay? So I have, whoops, let me highlight, not draw. I have this diagonal, and this diagonal. And what I have to do here is find the products of those 3 diagonals. So in diagonal 1, I have 0 times -1 times 1, that's 0. In diagonal 2, I have 2 times 2 times 4. That's going to be 4 times 4 is 16. And in diagonal 3, I have 1 times 3 times 0, which is 0. I'm going to end up adding those all together. Okay? So I have 0 plus 16 plus 0. That's my, so far, what I've had to do. Now the second part of this is I'm going to start with the last element in the first row, which is 1. And I'm going to highlight diagonals that go backwards now. Okay, so I'm going backwards. So these are the ones that I will end up subtracting. So now I've got 1 times -1 times 4 is -4. 0 times 2 times 0 is 0. And 2 times 3 times 1 is 6. And I'm going to take those 3 numbers and I'm going to subtract them. So I'm going to subtract -4. I'm going to subtract 0. And I'm going to subtract 6. And at this point, it's just a matter of some pretty basic mathematics. So 0 plus 16 plus 0, let me do this way, is 16. And then I have plus 4 minus 6. So 0 plus 16, 16 plus 4 is 20. 20 minus 6 is 14. So the determinant of this matrix ends up being 14. All right, I'd like you guys to try the next one on your paper. So you can pause the video here, come back when you're done, and check your answer. Okay, so here you go, and I've kind of highlighted things, and I put the products so they weren't all across the bottom row there because that can get a little confusing. I put the blue ones across the top. So we add the red ones and subtract the blue ones, and when you do that, you get -27. Now, this is great if we have a 3x3 matrix, but imagine, this would become a lot more intensive if we had a larger matrix. So a 2x2 matrix is pretty quick. A 3x3 matrix also pretty quick. But beyond that, it doesn't make sense to do this by hand. So let's go ahead and talk about how you do this using your graphing calculator or Desmos. All right. So in order to actually find the determinant of a 4x4 matrix by hand, a little bit more goes into it than just what we did with the diagonals. It actually is based on finding determinants of smaller matrices inside of the larger matrix. So it would have us finding the determinant of a 3x3 matrix that's nestled inside of the 4x4 matrix, and then finding other 3x3 matrices inside that as well. It becomes a pretty intense process. So anything beyond a 3x3, it makes sense for us to use some technology to do so. And this is pretty easy to do. If you're using your graphing calculator, when you go into the matrix menu, there's a third menu that we really haven't talked about yet, and that's the math menu here. We've looked at the edit menu and the names menu in order to actually create our matrices, but we can now use that determinant to actually find the determinant. So the first thing you would have to do is enter in your matrix with the edit option, and then go into your main screen and find the determinant by using this determinant option. Now you can also use Desmos. We've talked about our Desmos matrix calculator. you would just enter your matrix into Desmos, and then there is a key in your matrix menu that says DET, that's to find your determinant. So either one of those is a viable option. What I'd like you to do right now is try to find the determinant of matrix A above using your graphing calculator or Desmos, and come back and check your work once you've finished. All right, hopefully that didn't take too long. Obviously, the hardest part about this is making sure you've have your matrix entered into your calculator or Desmos properly, and then just find the determinant using the function for determinant. And you should get that the determinant is 16. If you did not get this, please make sure you go back and double check that you've entered your matrix correctly. If you entered your matrix correctly and you're still not able to get this, let me know and we can take a look at it in class. In the next lesson, we will take a closer look at a couple of other applications, but I wanted to do these two today because they're pretty quick and they're a natural kind of application for determinants. So if I wanted to find the area of a triangle that's graphed in the coordinate plane, I can do so very easily with a determinant by finding the determinant of a matrix that's composed of the 3 ordered pairs and then 1 column of ones. So let's go ahead and take a look at what this would look like for our triangle here. So this triangle, we can label our points in any way we'd like. I can call them like I am here, x1, y1, 4, 3, x2, y2 is 2, 2, and x3, y3 is 1, 0. But I could also rename those in any order I'd like. So I could call 2, 2, x1, and y1 if I really wanted to. Now, if I'm going to find the area, I'm going to put in those values into that determinant that I see written above. Notice that there's a plus or minus in front of it, and that's because we know that area needs to be positive. So whatever we get, if we get a negative number for our determinant, we're going to multiply it by -1/2 because our final result needs to be positive. The determinant does not know that it's finding the area, so it's going to give you possibly a negative answer. So let's go ahead and put in our points. So I'd have 4, 3, 1. That last column is always just composed of ones. And then we have 2, 2, and 1, 0. So we're going to find the determinant of this. Once again, I'm going to use my graphing technology for this. You're welcome to do it by hand if you would like, but I find that it's pretty easy to do this one on the graphing calculator. So let's go ahead and put your matrix into your calculator, find the determinant, and see what we get. I got the determinant was equal to +3. So then I know that I'm going to multiply by +1/2. So I would rewrite this as 1/2 times 3, which I can then write as 1.5 or 3/2. I don't have any unit of measure, so I'm just going to say units squared, and that is the area of the triangle to the left. Why don't you try the one below here? Now I'm just giving you the 3 ordered pairs. So go ahead and pause the video, try this one, come back and check your answer when you're finished. All right, take a second, kind of look over what I have written down. You'll notice that this time my determinant ended up being negative. So because I need to get a positive value for my area, I'm going to multiply by -1/2. Okay, one last quick application here, and it's pretty much directly related to what we just did. If I wanted to determine if 3 points were collinear, collinear meaning they lie on the same line. So there's only 2 options. Either all 3 points lie on the same line, right? They lie on the same line, or they don't. And if they don't, those 3 points will create a triangle. So if I use this area of a triangle that we just talked about, the formula up above, and this ends up and our area ends up being 0, it can't be this triangle. It has to be a line. So we're going to use the area formula. We're going to use our 3 ordered pairs, and we're going to plug them in, use our calculator, find the determinant. And if the determinant ends up being 0, then we have no triangle. It has to be collinear points. Okay? So I would set this up, and we can do kind of the same thing we did before. Now the difference is I'm only concerned about whether or not the determinant ends up being 0. So I don't really need to worry about the 1/2. I'm not actually finding an area. So we're just going to see if the determinant, and I'll call it A, equals 0, then the points are collinear. So we're just going to create a determinant matrix here and see if it ends up being 0. And just like above, I would call these x1, y1, x2, y2, and then x3, y3. Now, you'll notice they use A, B, C, D, E, and F. It's just another different notation. Guys, it's the same exact formula. A is x1, B is x2, or y1, et cetera, et cetera, et cetera. So our determinant is just going to be like we did up above, negative 113, negative 343, 1. That last column is always 1. And then you end up with this determinant. Now we just have to see if it's 0. If it's 0, then the points are collinear. So go ahead and try this, plug it into your calculator, see what you get, and come back and check your answer. So we have this determinant does in fact end up being 0. So what that tells us is that we are in this situation where there's no triangle being formed, which means those 3 points have to be on the same line. So what we can say from that is the points are collinear. All right, we'll do some more applications in the next lesson. Just wanted to give you a little taste of what's to come.